Let's do it.
Great. So first question, what sparked your interest in neuroscience and what do you foresee for the future of the field?
What sparked my interest is I was taking a lot of philosophy classes and just got very interested in this question of what is the perceptual machinery by which we view the world? And I realized that we could get a lot farther in this question if we understood the perceptual machinery by which we view the world around us. And so I got fascinated by neuroscience. Also, my father was a psychiatrist and my mother was a biology teacher, so it sort of helped steer me in this way. And as far as the future of the field, I think a lot of the big next steps have to do with improving our technology, because we have no shortage of ideas about theoretical ideas about things, but what we actually need are better ways of measuring what's going on in the brain so we can measure the activity of 86 billion neurons in real time. That sort of thing would really move the field forward, because right now we only have very crude ways of measuring what's happening in the brain.
Thank you. Yeah. If anyone has questions, feel free to raise your hand and I can call on you. We did receive a question on our social media, so I'll read some of those as well. So one question, there is a hypothesis saying that the subconscious mind does not distinguish reality from imagination. What do you think about that, and how do you correlate this with neuroplasticity and live wiring?
One might mean various things by that question, but perhaps one of the most interesting things about the brain is that we are constantly simulating possibilities. So if the questioner meant, reality and fantasy or simulation, then it's not that the brain doesn't distinguish those, but it's that we live much of our lives in this situation of fantasy, in the sense of saying, okay, look, this is exactly what's going on now, but what if I do that? What if I were to do that instead? What if I had done that? What if someone else were to do that over there? All of these things are what allows our species to be so successful, because instead of having to try everything out ourselves, we're able to run the simulation in our minds and then assess the consequences. So it's not that the brain can't distinguish those, but it does spend much of its time in storytelling mode.
Very interesting. I think we have a hand from Ashley. So if you want, just say like your name, where you're from, and then your question for Dr. Eagleman.
Okay, hi, I'm Ashley. I'm from Connecticut. My question, to watch the show that I was younger, and it was one of the main drives that got me into neuroscience and broader cognitive science, which I now want to spend my life working in. So what advice or recommendations do you have for creating accurate but accessible scientific communication?
I think it's the most important thing in the world to communicate science, and this is for several reasons. I mean, one basic reason is that all of science is funded by the taxpayers, and it's really useful to tell people what we're learning. But more than that, it's that, this is the most amazing stuff we have, and on this mission of trying to understand ourselves and our lives and what we're doing here, and how this all works, what better pursuit than diving in and trying to figure out who we are, and sharing that with the public is incredibly useful. I was just visiting Nike's campus in Oregon, because I'm doing a little consulting with them, and I went around and there are all these giant buildings dedicated to these athletes, the Serena Williams building and the LeBron James building and so on. And I sort of felt like, wow, I'm really amazed that given these games, there's whole empires built to these people. But when it comes to something like public communication of science, that feels to me like way deeper and more important, and stuff that people maybe should be building, buildings to and so on, and talking about, wow, here's actually how the brain works, or here's what's going on in space, or here's how the microscopic world does these incredible hive mind things to accomplish all kinds of stuff, and here's how botany works and so on. Anyway, to me, that stuff is more beautiful and more fundamental. And so I look forward to the day when we all get to go visit some campus like Nike campus and see all the great stuff about public communication. In answer to your question, Ashley, about just how to do it, what you said is that's exactly the thing. How do you say something that's accurate? And that's the first really important thing for anyone who's interested in science communication. How do you make sure you're getting it right? You do the research, you make sure you understand it all the way down, you're not saying something wrong. And then the second thing is, how do you communicate it in a way that your grandmother would understand exactly what you mean? And until you can do that, you don't understand it yourself. And so you got to keep working on it until you understand something so clearly that you can just say it simply, and everyone who doesn't have any background in it might say, oh, wow, I really get that.
Yeah, it's definitely important that we're doing great science, but also communicating it well.
Exactly.
We have a question from Haneen.
Haneen, you're on mute. Veda, do you have to unmute somebody, or are they able to unmute themselves?
You can ask to unmute.
Yeah, I don't know if they're able to see the request though.
Is my voice clear?
Oh, we can hear you now. Yes.
Yeah, hi, Dr. David. My name is Haneen. I'm from Iraq. You actually inspired me to become a neuroscientist. I first read your book about the brain when I was 16, and I got inspired. And since then, I wanted to become a neuroscientist. I'm 24 right now, by the way, and I'm about to do a master's. My question to you is how to be a successful neuroscientist, especially how to be an innovative neuroscientist. What's your advice on this?
Yeah. The main thing I would say is just find the things that you love and really pursue those. So what I mean by that is the field of neuroscience at this point is enormous. It's so, if you go to the national meeting, the Society for Neuroscience meeting, there's 33,000 people there. It's just, you can do anything from molecular all the way to cognitive neuroscience to other things too. And so to my mind, the important thing is to walk up and down those vast fields of posters and figure out what thing really turns you on, what makes you say, oh my God, that is the most amazing thing. Because there are a million people who will tell you what you're supposed to like in the field, but for each of us, it's figuring out our own path is the important part. And so once you've got that, then it's easy to stay up all night and work on problems and read the literature and figure things out and publish it. And then, the key is science is a long road, which is to say, for you to get your first paper, your first result, takes a long time, takes years. But so you have to make sure you're doing a problem that you're enjoying the journey on. But it sounds to me, Haneen, like you've already got, what it takes, which is you've got the heart and the spirit behind it to carry you through that.
Yeah, neuroscience is such an interdisciplinary field. There's so many different ways to explore it.
Yeah. Exactly.
Noan, sorry if I'm mispronouncing your name.
Yeah. So you can hear me, right?
Yes, we can hear you.
Okay. Dr. David, it's my pleasure to talk to you, and it's amazing. So I have a couple of questions. My first question is it's about the vision. So do you really believe what really do we really see what we believe, what we're seeing? For example, there's no such thing called colors. right? So my question is like, do we really see or do we really measure the physicality?
So I think I understand the question. This comes down to this very fascinating issue about qualia, which is your private, subjective, internal experience about something. So yes, we think there are colors in the world, but colors don't actually exist. There's only different wavelengths of light. We might all see colors differently. And of course, some people here are colorblind and things like that. And so, we have these internal experiences, and it's part of the illusion. It's part of what gets constructed for us on the outside. I mean, let me do it this way. The thing that's so fascinating about vision and hearing is that we think we're seeing and hearing things out there, but of course it's all happening in here. You have air compression waves hitting your eardrums, and that gets turned into, through a series of things, into electrical spikes in the brain which run around. But you don't feel that way. You just feel like you're hearing my voice. I'm just talking to you, or you're looking out at the world there. But in fact, in the darkness, it's spikes running around, and that's what you believe you're seeing out there. So this is one of the really fundamental questions in neuroscience, is how this all works. We don't yet know the answers to these things, and it's, to my mind, why it's such an exciting area to be studying in. But yes, so the brain sees and hears and perceives what generally is useful to it, and not other things.
Okay, so can I ask you another question?
Sure.
Very quickly. So my question, it's very simple, but in deep. Are we conscious all the time?
No. So for example, at least a third of your life when you're in deep sleep, you're not conscious at all. And then of course we are generally conscious when we're awake, but it's such a limited window that we're seeing, right? So if I'm listening to a podcast, I might be really conscious of that and therefore not conscious of what's visually in front of me. And other times I'm looking in a microscope and I'm really conscious of what's visually in front of me there, but I'm not conscious of, somebody talking across the way. And so, we're conscious of just little bits of of things that are out there, but yeah, and then we have whole windows of time where we're not conscious at all.
Thank you. And I think we're coming really close on time, so we can squeeze in one more question. Aria?
Yes, hello.
Hi.
Can you hear me?
Yes, we can.
Okay. I was wondering, is it possible to either stop the progress of Alzheimer's or like neurodegenerative diseases? Or is there like a cure or like coming up?
So the answer is, indeed, there will be a cure coming up, but we have no idea if that'll be 5 years or 50. So it's the brain is an extraordinarily complicated system, as most of you probably know. It's 86 billion neurons. A single neuron is as complicated as a city. Every neuron in your brain has the entire human genome in it. It's trafficking millions of proteins around. Cells are plugging and unplugging and replugging. It's unbelievably complicated. And we don't have really good technologies to see inside of neurons and see the life of a single neuron, much less the interaction of 86 billion of them. So, I would say what's been going on with Alzheimer's or other diseases, is this issue of trying to get the lowest hanging fruit first. Like, oh, maybe if we just attack the plaques and the tangles that we can see with Alzheimer's, maybe that'll solve it. And so for the last 20 years, that's been the mission. And I think the field is coming to a conclusion now, which is that is not sufficient. Somehow the plaques and the tangles that you get with Alzheimer's are just sort of the exhaust coming off of the machine rather than the problem itself. And so pharmaceutically attacking those doesn't do anything. So we don't have a cure for that, for something like Alzheimer's or many other forms of dementia. I have no doubt that we will. but it's just a matter of time. The good news is there are labs all around the world studying this and doing good work on this. We just don't know when the breakthroughs are going to happen. I can take, Veda, for what it's worth, I can take 4 more minutes and then I have to jump.
4 minutes. Okay, sure. Yeah. I
I
don't
saw-
see any other hands.
I saw there was another hand up, but then it went away. If you
Oh.
want to put your hand back up, anyway. Okay.
Well, another question we received on the Zoom registration. How does neuroscience relate to law? And how do you relate neuroscience to other, distant fields?
Yeah, that's actually been one of my big guilty pleasures, is always doing those sorts of relations. So some of you may know I run a national nonprofit on the intersection of neuroscience and the legal system. And essentially what that has to do with is, people are so different, brains are so different from one to another. And for better or worse, in the legal system, the legal system treats everybody the same. And so you assume that all brains are the same. There's this reasonable man standard, which is what would a reasonable person do if they walked into a room and saw the situation? And the fact is that's just not supported by neuroscience. It's just not the way that things go. So my interest is in what can we do instead of imagining that incarceration is a one-size-fits-all solution. How can we understand the person in front of the bench better so that we know what to do moving forward? It's not that anybody gets off the hook. If somebody has committed a crime, we still have to get them off the street to, make society safe. But it is to say, instead of putting you in jail, look, this person over here has got schizophrenia. This person's got psychopathy. This person is tweaked out on drugs. This person is deeply impoverished. This person has a brain tumor. There are different things to be done in terms of rehabilitative strategies, rather than treating everybody exactly the same, which is what we do now. And by the way, so neuroscience and the law is one of the classes that I teach at Stanford. I also teach a class that'll start next month called The Brain in Literature, which is, just a cool, I really enjoy taking these cross-disciplinary issues. And that's about, why and how the brain is so good at constructing stories, and why we are so good at looking at arbitrary squiggles on a page and diving right into somebody else's shoes and feeling like we are in somebody else's story. Why is it that it's so easy to do that? Okay.
Thank you. Yeah. Lorelia?
Yeah, hello, Dr. Joe. Hello, Dr. Eagleman. You are one of my favorite authors, and I read all your books. So the question is this: what do you suggest it happens in the brain during a lucid dream night? I heard you saying that in deep sleep, during theta or delta, it's impossible for consciousness to arise. So you can't notice that you're dreaming. But in a lucid dream, I also experienced that, you are so aware that you're dreaming, and sometimes you can control the action in that dream. So what is that about?
Okay, so a couple things. When you're asleep, so what I mentioned is when you're in deep sleep, you're not conscious. So when you sleep, you go through all these cycles. Deep sleep, you're definitely not conscious. But in the lightest stage of sleep, that's when you're dreaming. So normally we dream during REM sleep, rapid eye movement. And so that's when you can enter a lucid dream where you take control of your dream. And that both REM sleep and lucid dreaming, which are close cousins, those are both forms of consciousness. But that's only a tiny fraction of the night. And that's why I said that, for the most part, when you sleep, especially deep sleep, you are not conscious. But yes, you can have these forms of consciousness. And essentially what it comes down to is when you go to sleep, your entire brain does this massive changeover to be in this different state of sleeping and dreaming. And then when you wake up, it does this massive change to get back into its waking state. And what can happen is that you get various states in between sometimes where the whole factory doesn't do a switch over cleanly, but can be sort of stuck in between. And that's when you get something like a lucid dream. Thanks.
Thank you. All right. I think at this point we have to wrap up the AMA. Thank you so much for your time. It's been really great hearing your answers and hope everyone, learns something. But yeah, thank you guys
All
for
right.
coming.
Great. Thank you so much for being here. I'm sorry that this was so short. Maybe we can do this again with a longer time scale at some point. And thank you, and keep in touch.
Thank you. Bye.